All right, so we are busy dealing with arrays still, so I figure, though, I still want to get started with the next portion of the lecture, where basically things finally come into focus for all the stuff we've been doing for our programming. And yeah, so it does seem like you've got homework, but it doesn't have due dates. I'll give you guys due dates well into a week away. And then we'll also figure out the time for our next exam, but we'll figure out, again, I haven't had due dates for a while because due dates have been crashing on me, and now I think I fixed it. So, and again, just tell me if you need extensions, but let's go ahead and talk about the new, so let's go ahead and talk about objects. New Java class. So we've talked about how to make, basically, we mentioned previously that there's three types of Java files, right? We have programs, right, which are some things you run, and then you have files. So you have programs and you have modules, which have a bunch of helper functions that we can use. So the third type of thing is a class, which, you know, we've been creating new classes all the time. So let's actually figure out what that is. Okay. With the most basic kind of thing there is. So I'm going to create two files here. Okay. The first we'll call point, and the other one I'm just going to call runner, which is what we're going to do. So what is an object and what is a class? The point of an object is that, and a class, is that they model something that exists in real life, or not necessarily in real life, but also an abstract thing. So, for instance, you can create an object. You can create a class called car to represent a car. You can create a class called highway to represent the highway that cars drive down. You can create a class called driver to represent the person who's driving the car, a class called passenger to represent each person driving the car. You can basically, the point of object-oriented programming is that you create objects, and then you write your program based on how those objects will all interact with each other. And you can go into it, and you go into as intricate detail as you need, which is usually not as intricate of a detail as you suspect you need. So we're going to start by basically modeling the most basic object I can think of, okay, which is a point. Okay, a point. So, right, you have a coordinate plane. Okay, we're not going to bother modeling the coordinate plane because we don't need to. If you've got a points, then the plane exists, whether we care about it or not. But remember, what is a point, right? It's some point on this coordinate plane, right? So let's talk about it. What does a point consist of? What does a point on a coordinate plane consist of? X and Y, that's it, right? Other things are just basically differences in how you're, on what ink color I'm using, right? It's an X and Y point. It's got an X and a Y coordinate. So that is what we're going to model, something very simple. So in our runner, so let's go ahead. So essentially writing your own class, defining your own data type is super easy. Points have an X and a Y. So let's list that. Okay? And since remember, we're in a coordinate plane, they have either they're real numbers, right? Not integers. So we'll use doubles. So points have a X coordinate, and they have a Y coordinate. Makes sense so far? That's simple enough. Okay. So notice that it compiled just fine. I just put double X, double Y. I just simply listed the attributes of a point. So objects, when you write something like an object, it's basically made up of two parts. The first part is attributes. What the object has, and behaviors, or what the object can do. In other words, these are the variables and then you have the methods, right? You have your adjectives or nouns, depending on how you look at it, and then you got your verbs, right? Right now, we're not going to care about what a point can do, right? Points just stay there from our perspective, right? So let's go ahead and see now. Remember, runner has to be in the same folder as the same package as your point in order for this to work. So let's go ahead and create a new point. Point P is equal to a new point. That's it. We have created our first point just by doing that. Okay? So we've created a new point. It's come into existence. Let's go ahead and check its x and y. So let's go ahead and set its. So now how do I use it? For instance, I can't print out the point. It's so basic it doesn't even know how to print itself out. If I try to print out the point, it says objects.point, or whatever package you put it in, right? I'm in the objects package. It says objects.point at a memory location, just like how an integer array would say, I'm an integer array at this memory location, right? It's such a basic thing, it doesn't even know how to print itself out yet. We'll teach it how to print itself out. That's a behavior that we'll get to. But right now, we're just focusing on its attributes. The next thing we can do is set those attributes. We can set its x-coordinate by going p.x is equal to, let's say its x-coordinate when we want it to be 5, and we want its y-coordinate to be 0. So now we can print out p.x plus space plus p.y, right? It has an x and it has a y. So here we can set the values of the coordinate plane values, and we can retrieve the values, right? So the point stores the values. So what does it mean to be a class? The class is a blueprint. When we use it to build point objects. The class is what we use over here when we go point P is new point. This builds a point object. The class is the blueprint for building points. So, and each point, this point P, has its own x and y values. That makes sense to everybody, right? I'm going to go ahead and make another point. Point other. We don't like it because it's the other, right? Point P is equal to a new point. It's a different point. Other has its own x, and we'll set it equal to -7. Other.y is equal to -200, right? So let's go ahead and copy this printout line, and let's go ahead and print out the x value, the other x, and the other y. And this makes sense that basically that P has its own x values, which get printed out, and other has its own x values that get printed out, right? P has its own values, other has its own values, which are different. Everybody understand that basically each point object has its own copy of x and its own copy of y, right? That makes sense to everybody? It's pretty basic stuff right here so far, okay? It's fairly simple to make these things. Okay. Let's go ahead, though, and ask ourselves, what if I don't set up x and y by default? What happens then? Then it's at 0, 0, right? By default, right, it's x and they're doubles, so they have to have values. If I don't set up other to have something, then it'll have 0, 0. Okay. So this represents an xy coordinate. So I lied when I said there were 2 sections. There's actually 3. The third, which we'll get into. The third one is the middle one is called Constructors, which is how to build an object. But right now, so you also have to tell your program how to build an object. So how do we build it if I need a section of code that tells me how to build it? How did I create a new point when I just said that you have 3 sections, right? What it has, how to build it, what an object can do. And how am I building it if I have no instructions? The answer is kind of obvious, which means, well, maybe you don't need it. Maybe instead Java gives you something for free if you don't have it. And that's exactly what happens. If you don't provide instructions on how to build your point object, then it just builds it on its own. So let's go ahead, before we focus on how to do constructors, let's teach it how to, let's go ahead and teach it how to do some stuff. Maybe, let's go ahead and tell it to do something. For right now, let's go ahead and make a print method. So this is a method an object can do. So notice that this is going to be there's a very important difference when we're writing this for an object. That this is something an individual object can take. An action an individual object takes rather than the class. Public void print coordinates. So notice the lack of a static there. The static, so a static means it's a class method. When it's not got static, it means it's an instance method, which means it's an action that refers to to an individual object. So zout, because remember I'm putting a print here. Now normally we're never going to have something like print line in an object, but just simply because we're working in, we're starting out with this, that's the only reason we're going to do this. We can do this, and I'll show you the correct, and I'll almost show you the correct way to do it in basically 2 minutes after I do this. Print x plus y. So now you might be asking, wait, this should be giving me an error. First off, the print line's fine, but I don't have a static there, which I told you is okay if it's a void method, if it's a instance. But it doesn't have, where's x and y coming from? Well, they're coming from here. Now you might notice that basically your IDE might be giving them a different color than they normally give here. So if I do int a is equal to 5, zout a, right? Notice that in here a local variable over here, a local variable that exists inside of a method, it comes out black. These variables that I just wrote come out in they're in color. They're in my IDE they're red. I think in Eclipse they might be blue, and then NetBeans are probably a different color as well. So where is it finding x and y? Well, they're the attributes that an individual point has reference to. So now how do I tell each point to print its coordinates? It's fairly straightforward. I tell p dot, and now look, it has a list of methods that I wrote. Print coordinates. And I run it, and it prints its coordinates, 5 and 0. So this is fairly cool, right? You can make your own data types to represent anything you need, right? So, all right. Believe it or not, that's pretty much all there is to an object. But we're going to refine so let's go with another example. So I like using geometry, very basic geometry, by the way, for these kind of things. So let's go ahead and use another geometric example that's very easy for us to calculate stuff for. We're going to go with the rectangle. Okay? So let's go ahead and define a rectangle, right? What are the attributes that define a rectangle? From a mathematical point of view.
4 points.
4 points, that's one way to look at it. So you can use the 4 points, but it's not, but because it's a rectangle, they'll be at you only really need 1 point, right? It's x and y, right? One of the corners, and then you can figure the rest out from the other bits, which is So, but we can use it. But we'll get to the points in a bit. But like from an abstract rectangle that just exists on a piece of paper, what do you need to do any kind of calculations on it? The length and the width, right? Or the width and the height, depending on how you want to talk about it. So let's go with it needs the double length. So it needs to know the length and double height. And what's cool actually is that cool trick here. Watch this, comma. You can actually declare multiple variables at once like this. Double length, height, like that. Okay. So that's again the attributes for it. So so I can create a new. So let's go ahead and comment out this stuff from the beginning. Okay. So I can create a new rectangle pretty straightforward just by going rectangle R is equal to a new rectangle, right? And that will create a new rectangle with the attributes of having a length and width equal to 0, which really doesn't make sense for a rectangle, right? They should have some initial width. So what we can do instead is that we can give instructions on how you build a rectangle, like this, okay? So let's go, so right, these are the attributes over here. So let's go ahead and give Java instructions on how to build it. How to build, so you build things with a constructor. Now constructors are so easy that most of the time, most of the time a constructor is so easy that I can do this. I can go code, completion. So now completion. See, I've never actually done it in here actually. I've done it in Eclipse and in NetBeans, but I've never actually done it in here. Let's see. Generate, alt insert. There we go. Generate constructor, and have it automatically write the code for me, which produces a bunch of code that you don't understand right now. So let's go ahead and understand it instead by writing it ourselves. To give instructions on how to write, on how to build your own class, you got to create what's called a constructor, which is as follows: public, followed by the name of your class. You use public because you want people to be able to build your class, build objects. If you don't want people to build your object, you go private and tell them you don't want to build it. But in most cases, we want to be able to build it. So we go public rectangle, and we give it, and we would say maybe, and then it acts like a method with parameters and stuff. Double initial length, right? Initial length to represent the length, and double initial height. And then we just, right, we want the user to provide a initial length and initial height to build the object. We don't want it to just be 0, 0. And then we'll say length is equal to the initial length, and then height is equal to the initial height. Okay. And then behaviors, in other words, the methods. What can we do this? So one thing that I would really like is for is that, right, if I do this, build a rectangle, now I have an error here because I can't, because it's saying, hey, it doesn't have it, you need to use, the constructor says to provide 2 things, right? You didn't provide 2 things. So let's create an initial length, 5.0, and initial height is 1.0, right? And so notice, remember that this grayish text here, right? That's not actually text you need to type in. That's something that my IDE pops up with. Okay. Of course, if I want to print out the rectangle, it just simply says, hey, you know this. So let's go ahead and talk about what's going on here. Java gives you a whole lot of methods for free, right? If I go r dot, it says I have the length and the height, but notice that there's a bunch of methods over here that I never wrote, and it says I wrote. There's equals, there's hash code, there's toString, notify, notify all, wait, right? There's all these methods that basically come for free. Whenever you write an object, for reasons that we'll learn later, you get a bunch of stuff for free. The two most important are equals and toString. So whenever you pass any kind of object, like a string, or a scanner, or anything you write into a printline statement, any object that gets passed into a printline statement, what Java does is that it automatically adds the .toString method to turn your object into a string so it can get printed out. So what we're going to do, now if you don't write it, now because the toString method is so important, if you do not write one, Java automatically writes one for you. Okay, that makes sense? Because the toString method, it assumes that you want, printing out your object is such a common thing that it assumes you want to be able to print it out. So if you don't define how to print it out, Java automatically defines a way to print it out for you. So let's go ahead and write our own toString method. And once Java sees we have our own toString method, we'll be able to write our own, we'll be able to define how we wanted to print it out. So to write our toString method, toString methods return a string, so we write public string, and the name is toString. It doesn't take any parameters in, and then we just simply return whatever we want to be replaced for our string. So for instance, if I return just mashing on my keyboard, okay, as the string, def kidjal fanal ha, right, then it will, instead of printing that out, it will do daf sniff ha, right? And it's not, and remember, whenever I print out something, it automatically calls that toString method. So it's going to print that out now. So let's actually print out something useful, such as I am a rectangle with length plus length and plus and height plus, right? Makes sense? And now if I print this out, if I run this, I can't run this class, but if I run our runner again, I'm a rectangle with a length 5.0 and height 1.0. So now we can define how our objects get printed out. Make sense to everybody? So what other things can we do with these things? We can, I choose, rectangles specifically because they, unlike points, we can do some pretty trivial calculations with them. Like, we can calculate the perimeter of a rectangle, right? That's an action that we can do on these. So like public, so what data type would the perimeter be? A double, right? Because these are doubles. So doublet void get perimeter, right? Public double get perimeter. We don't need to pass anything in. We don't need any extra information. All we need is the information that's stored in the rectangle, right? So to get perimeter, we just need the length. To calculate the perimeter, we just need the length and the height, right? How do you calculate the perimeter of a rectangle again? Just all the sides added together. So you have two sides of length, and you have two sides of height. So you add those all together, so that will give us our answer. So we can just do that in one line. Return twice the height plus twice the length. Right? And notice that it comes up again red just to show in my IDE, just to show that this is whatchamacallit. And these are attributes. They are instance variables. So now, instead of printing out rectangle, I can do something like print out the get perimeter, which will do 12, which is twice the, which is 5 plus 5 plus 1 plus 1, twice the length plus twice the height. What about the area of a rectangle? What's the formula for area of a rectangle? It's length times width. So we just do public double get area. And we don't need to provide anything else, right? A lot of times we don't need to provide anything else. Return length times width. Oh, well, we called it height, right? There are two variables, are length and height here. So you created a new variable, and notice that if you go to R and do R dot, it should pop up with yet another suggestion for you. The get area we just wrote. So 5 and 1, its area is of course 5, right? So it has some behaviors. It has attributes. Okay? Now, this is all the basics of, now believe it or not, this is the basics of writing the class, and they're fairly straightforward, right? There are 3 categories of things you write for a class, right? The attributes, what they have, the constructors, how to build them, and behaviors, the methods you can call on them. Okay? Everything else for these things falls under the categories of object-oriented programming, which are 3. Encapsulation, inheritance, and polymorphism, which is basically scary word, other scary word that basically computer scientists came up with to make things sound scary, which they're really not. Even though they do, it seems like the concepts they introduce are complex. They're not too bad actually. Everything though for the basics else covers encapsulation, and we'll get into that on the next lecture. But that's stuff like doing private over here, so people can't change your stuff, or making methods private, so people can't use certain methods because you don't want them to use certain methods, right? Or using the this keyword to access things inside, and to do things like overloading and overriding. Those kinds of things, well, overloading specifically, overriding gets into inheritance. But the basics, the rest of it is encapsulation, which is basically making little small components and making sure they only behave in the way that you want them to. But otherwise, you currently know enough to write the rectangle class. You'll find that these things are a bit easier to deal with in arrays. They just require a paradigm shift, a way to thinking about programming that you're not normally used to. Right now, we're just focusing on building them for the sake of building them, not for the sake of doing anything with them. We're going to build up to something called the game of life, where we're going to build a representation of a board, and basically build something called the game of life, which is a 0-player game. And so we'll build up to that. And then what we're going to build up to with that is actually a much more complex project, where I will give you, which David was kind enough to confirm it did work on it. So we'll build up to that, where I give you a much more complicated project that works, where it works completely. And your job is to basically just complete a method in there so that it runs much more intelligently.